Namaste and welcome to CADEC learning series. In this video, we'll see uh, the functionality of CADEC Basic, which is a standalone configurator which can work with or without SolidWorks. Uh, First of all, we'll see what are the salient features of CADEC Basic and what is the difference between CADEC Pro and CADEC Basic. This is a user interface of CADEC Basic. You will see that it's a standalone application, and whenever required it can open SolidWorks if required. Most of the configurator work doesn't need SolidWorks. For example, for creating design calculations or for linking the variables and parameters uh, and various rule definition, we really don't require SolidWorks. That's the reason why there is a need for CADEC Basic. Another reason is some applications which are design configurator, they don't need a CAD output at all. So they need costing output or they need data sheet or quotation output. So they actually don't need SolidWorks. So that is also a reason why CADEC Basic is required by many of our customers and used by many of the customers also. Another reason of CADEC Basic is it has a very simple workflow. You can create a new class, you can modify a class, or you can create design using an existing class. Another reason of using CADEC Basic is it's a very useful knowledge capture tool for senior management. Typically, senior managers don't have SolidWorks installed on their computers. Many of them don't know how to use SolidWorks also. But they have a lot of knowledge which needs to be captured. They want to review the knowledge captured by their design engineers. So any CADEC Pro application can be opened, reviewed, modified using CADEC Basic. That's another great advantage for senior management. And CADEC Basic, whenever SolidWorks is required, and if it is available on your computer, it will open and utilize the SolidWorks functionality whenever required. So let us see some differences between CADEC Pro and CADEC Basic. So the operation is with SolidWorks and with or without SolidWorks. That is the first main difference. Second is the user profile. CADEC Pro has a lot of productivity functionality and a lot of detail functionality, uh, and CADEC Basic has all the essential functionality. CADEC Pro is more uh, targeted towards detailed design engineers, whereas CADEC Basic is targeted towards overall engineering managers. Then some of the functionalities, all the required functionalities are there in CADEC Basic. Some of the advanced rules, which are productivity functionality, which is not there in Basic. Similarly, crawl X, which is also a productivity functionality, which is not there in CADEC Basic. Some of the advanced drawing configurator functionality is also partially present in CADEC Basic. Then some of the productivity tools like import, export, custom properties, custom UI is also not provided in CADEC Basic. Rest all is available in CADEC Basic. Uh, to see the functionality of CADEC Basic in a demo, we'll use a sample application of a process tank. A process tank family can have variations like the top of the tank can be open or closed. Then agitation can be by stirrer or air coil. Bottom can be flat, conical, or tapered. Resting can be on bottom plate or stiffeners or legs. So this was the shape variation. In the size variation, we'll first the user first has to specify the fluid flow in meter cube per hour. We can also specify a range for that. Similarly, retention time can be specified. Then tank height can be specified. Then the tank capacity is flow into retention time. Then tank ID is square root of capacity divided by cross sectional area of the tank. Then tank OD can be calculated from ID. Then inlet connection diameter and outlet connection diameter can be chosen from a fixed list. Side glass can be also chosen from a fixed list, and some of the other side glass parameters can be uh, derived from a lookup table based on side glass. So this is the example. Let us create that example in CADEC Basic as a new application. So I'll create a new product class in CADEC Basic. So this is CADEC Basic user interface. Uh, you can see that in a class you can create a new class, open or add existing class. Then add existing means there can be some classes which are present in your older application, so they can also be added to this. In configure, you can define shape variables, size variables, linking user-defined functions. You can crawl the model. You can make mandatory and optional, that is shape linking. You can configure drawings. You can configure code. In design, you can create a new design. So here you will see that you can browse a existing product class or you can create a new class. So I'll add a new class. So I'll add a new class. I'll create a folder for that. Let's say my new class is concept uh, process tank, and I'll have to specify the name of the product class. So I'll say this is process tank concept. So I'll see that this process tank concept is now available as a new product class. So first I'll have to create some shape variations. So we saw that in the plan of the product family, we have defined some shape variation. So I'll specify, let's say top is open or closed. Then agitation can be using stirrer or air coil. I have added the shape variations. So these are the shape variations. I'll save this and I'll quickly check what application CADEC Basic has created. So I'll go to design new and this process tank concept, and I'll see that these options are created by CADEC Basic. Let me now go and define the calculation logic. So I'll need to specify flow in meter cube per hour. Then I'll specify tank height mm. So I've added some more variables. So they are flow, tank height, tank retention time, inlet connection, outlet connection. They are to be chosen from a fixed list. Then side glass size and side glass flange step and thickness are dependent on side glass using a lookup table. Then tank capacity is flow into retention time by 60. Then tank ID is square root of tank capacity divided by cross sectional area, and tank OD is tank ID plus 20. So I'll save this. We'll create a new design and check that these things are appearing over there. We need to create some rules now. So the uh, rules are, first is size rules, that is size lookup. So for inlet connection, we'll specify the connection diameter can be 25, 32, 40, 50, etc. For outlet connection, so I've created the size calculation rules, and we'll now check the design calculations. So I'll specify a layout ID. Let's say I'll give some value. It will tell me that the range is from 10 to 40. So maybe I'll take 30. Then this is maybe 2000. Retention time can be, let's say, 30. Inlet connection, outlet connection, SG size. I'll calculate. So the values are calculated accordingly. So with this, we can see that the uh, design calculations are created. We need to also create a model if we want the application to generate a 3D model and drawings. We can also generate a uh, quotation or data sheet or costing, which is a non-CAD application and it doesn't need SolidWorks. So we'll open SolidWorks and create the model required for this application. So this is the master model creation. So we'll create a very generalized and simple model of the tank to start with. So I'll create a new assembly. And I'll save it in the product class folder. So I'll choose the same assembly name as the product class. Now I'll add some parts to it. This is my ID, and this is the OD. I'll specify some height. And I'll save this as say shell. Then I'll create another part and call this as This is, let's say, the top, and I'll specify the OD for top. So I've created the two components, and I've created a assembly with some mates also. So within the shell, we have a boss extrude which has a ID, OD, and height, and then within top we have a boss extrude, and it has a diameter and thickness. So it's a simple assembly. So I will close SolidWorks. Now I'll go to our product class. Then we need to now, we have done the shape variables, size calculations, we have defined rules. We need to crawl the model now. So as we said, whenever required, CADEC Basic will utilize the SolidWorks functionality. So it will open SolidWorks and crawl the assembly. So CADEC Basic shows that there are two components in this, and uh, we can lock components if the components have no variations, but we want variations in our components, so we'll not lock any components. And I will crawl the assembly. So that means I'll get all the parts, features, parameters, sub-assemblies, etc. from that assembly. And uh, uh, after the crawl, I need to define what are the uh, mandatory functionality. So let me make shell as mandatory, and top can be optional. So I will save this. So CADEC Basic uh, has executed the mandatory functionality and made it enabled or unsuppressed. I will need to now configure the optional functionality, optional features. So if top is closed, then I'll make top as enabled, and I'll save this also. So our shape linking is also done. We'll now configure the size linking. So I'll go to size linking. So if you see, CADEC Basic has a very simple and logical workflow for new users, for senior users who want to capture their knowledge and create new applications. We'll also see the other use of reviewing a detailed application in CADEC Basic later in this demo. So we need to create parameter equations in which the parameters from SolidWorks, the parameters crawled or captured from SolidWorks on the left side and the design variables on the right side. So currently there are no parameter equations, and we'll go on adding this. So the height, we created the design variables in our variable table. So I'll choose the tank height from here. Then the ID. So I've created the required parameter equations, and I'll save this. So the next step is we'll create a design based on this. So I'll choose this product class. I'll specify, let's say, process tank 2502, and I'll specify some values here. I'll calculate and I'll modify. So this got modified to whatever values were calculated. So now the next phase is we'll create a drawing for this and configure it. So I'll first create a drawing in SolidWorks. I have created a simple master drafting for the assembly in SolidWorks. So I will save this in the same folder and I'll close this. Now I'll go to the product class and I'll configure drawing. So the drawing configurator needs to capture the drawing. I'll specify the folder in which the drawing can be found, and CADEC found this drawing. When I save this, CADEC Basic will capture the drawing uh, details and entities. I'll go to the configurator. The number of sheets will be found, and it found that there are 4 views. This is the drawing view 1, then 3 and 4 are in the first row, and drawing view 2 is in the second row. I can specify the margins, top, bottom, left, right, and in between. So let's say the bottom margin I want 70, and the right margin maybe 30 mm, and in between margins can be modified. And in uh, yeah, so I'll specify this and I'll save this. So our work of drawing configurator is done now, and we will go to new design, and we'll specify a layout ID. We can specify some inputs. See that the part gets modified, and we'll generate drawing for it. And it has done the modifications of the drawing and dimension alignment, view positioning, and view scaling, etc. So this was about how to create a new CADEC application and uh, configure it and use it. Now this was a very simple application. Let us now open an existing application created in CADEC Pro by a detailed design engineer. So I will close this and I'll close this and I'll open a process tank assembly detailed application, and we'll see what are the shape variables. So on the similar lines what we had specified in the concept application, but there are many more options provided here. Then the calculation logic also, you will see that it has got a lot of detailed calculations which are provided here. Then we'll see the design rules specified here, similar to what we had given in our application, concept application. Then we'll see the mandatory functionality here. Then we'll see the optional functionality here. and so on. So and we'll see the drawing configuration details also, and so on. So now we'll create a output using this particular uh, application. So I'll go and create a new design using process tag assembly. Then this is maybe p tank detail 2401. Let me say tank top closed. Then I may choose something from. So bottom plate is, let's say, what resting is legs. Then tank bottom is, let's say, flat. Agitator is air coil. Manhole is required, and so on. I'll calculate this. The various variables are calculated. I'll modify. So this got modified. We can see that the air coil is inside and various accessories are also there. Then we can generate drawing output for this. So that was about CADEC basic functionality overview. Thank you.